Okay, we are back on the Jaguar build, and if you remember from the last video, I finished the suspension and the steering rack except for the rubber boot, because I had to order something for that. So I got a pack of these bendy straws from Amazon, because I thought that that would be, the perfect thing for one of those boots. So I cut one up, cut it to size, and I'm thinking that that would work perfect on there. However, they don't fit over that piece right there. And as you can tell, I got the other side taken apart, and that piece is that piece right there. That's the swivel. So that rubber boot has to go over that swivel, and it doesn't. So I got a couple of ideas. I'm not real happy with either one of them, but I got to play around with this some more. But I'm going to put the steering boots on hold for now because I really want to get on the wheels. So if we take a look at the kit wheels, they don't look that bad. I mean, they could be better. They are just plastic. It would be nice to make those out of metal for the amount of detail I'm going for the rest of the car. So I don't want to destroy these. I don't want to cut these apart. So I'm taking measurements on these as best as I can. It'd be easier if I just cut the spokes off, so I'd have that piece in my hand to take the measurements from. So I'm doing the best I can without doing those, because worst case scenario, I will reuse the plastic wheels. Because again, they don't look bad. But they could be better. So with the dimensions I've been taking, I sketched one out, and I drew it to scale, but 4 times bigger. These are the dimensions that I got from the plastic wheel, as best as I could measure. And I've been looking at photos online of the actual wheels. When you look at images of wheels online, most of them curve around something like this, but there are some that just come straight up and angle out and then this way. The most common ones I've seen are like this. I think this is standard. I think this is original. This might be an aftermarket wheel somebody came up with. I really don't know. Feel free and let me know in the comments. But I think I'm going to try this way first, because this is the most, from what I've seen, this is the most common. This is more correct. This is how the kit is. I'm not sure what the story is behind these. So I think if I could make it like this, that would be better. But if I have too much of a hard time with that, then I could always go back and just do those, because they do exist, so it wouldn't be technically wrong. I have some material that I'm going to use. I've got a chunk of this. The outside diameter measured from the kit part is 25 millimeters, and this is 25.32. And I could take that back. I could take it to like 24. That flange doesn't have to be that big. So that's a non-critical dimension there. So that's plenty good enough there. This is my only chunk this big. It should be enough, to get 4 out of there as long as I don't screw up. I'm assuming I'm going to screw up at least 1, probably 2 or 3, who knows. So hopefully I've got enough to get that out of there. So I don't have a collet big enough for that, so I put it in the 3 draw, and I took it down until all of the run out was gone. What I was going for was 25. That's the outermost diameter. Again, that's not a critical dimension. That could be anywhere between, I don't know, 23 to 26 and be fine. So taking it to 24 and a half, and then I'll step down and do the 21, and then I'll just keep stepping those diameters down. So remember what I just said about screwing up. Yeah, my very first piece, I screwed up. I noticed there was a problem when I parted it off. So this is where I parted it off. So I was working from here over. So I got that recess carved in. I got the diameters. The diameters are perfect, but when I parted it off, there was no hole. And that hole should have been plenty deep enough. Somehow what I did was I made this area right here about 8 millimeters, and it should have been 5. So I don't know if I added the 3 here, or if I added the 3 here, or if I forgot to take into account the dimension of the cutter. I have no idea how I screwed that up, but this one is no good because it's too long. I can't shorten it because this is skinnier than this, and I'll lose pretty much all of that. So yeah, my first screw up was my first part. But with this, I noticed that when I put it on, it hits the brake. So I need to have that spaced out just a tiny bit. So I changed the dimension a little bit. I added more of a extension right there. So that's what this is right here. So I'm going to have a little bit sticking out here. About 2 1/4 millimeters is all I need. So yeah, this, I would have had to put some spacers. So yeah, this had other problems, even besides the fact that it's too long. I'd rather fix that. So let me take you over to the lathe and show you what I've got going on now. I decided to do it the other way and machine this way. And I think it's going to make it easier for me to not screw up again by doing that. So let's go see what's on the lathe. Okay, so I've got the diameters good. I've got the hole bored in for the spindle that the brake is on, and I opened that area up, and so this outside area there that has the Sharpie on it, that'll get the holes drilled in it for the spokes, and a screw and a washer will go in that end, and then this surface right around here, right around there is where the other spokes will go. You notice I've got a little bit of a curve shape, which is what I was after, and there is the form tool right there. So I kind of just eyeballed the shape on the grinder, and it worked out okay. It's not the exact perfect shape, but I think it's definitely good enough. If we move this over, just to kind of show you what I did, I first made the whole thing that diameter here, and then I covered it all in Sharpie, and then I brought this in, I brought that in, and touched off on the Sharpie, and then I turned it in to get my 11 millimeters, and then I just worked it out to the right a little bit to get that chamfer there, and then just moved it in to the left to get that curve profile in there. So that's pretty much what I did to get that shape. And I had to go around that outside with a file just to round that off a little bit more with a file, because I couldn't quite get that on the bench grinder. I couldn't get that tight of a curve in there. So I've got an inside curve and then the outside curve with the file. So that came out pretty good, I think. I'm pleased with that. What I'm going to do now, before I part this off, is, and I turned that in until I just had a little faint line of Sharpie left, and to get that round shape in there. But anyways, I don't think I specified this yet, or I don't think I said this yet, but the plan is to make all the wheel parts out of brass and then nickel plate it. I've always wanted to learn how to do nickel plating. I've done a ton of reading and YouTube watching, but I've never actually tried it yet. So this will be my first project where I need to nickel plate something. So to do that, this has to be like perfectly smooth. Any scratches or cut marks will show through the nickel plating. So before I part this off, I'm going to go over that with some sandpaper to get it like nice and smooth and not really polished, but it needs to be like smooth enough, like maybe almost polished. And when I cut it off, I need to make sure I leave plenty of room for the extension piece that I added onto the diagram. So And then I'll have to make some type of an arbor to hold that, to do the back side, which I'm gonna part off all 4 of those, and then I'll figure out how to machine in the back side, because I don't want to take this out and back in and out and back in. I'll lose concentricity for all of that. So I'm going to do this 4 times, and then I'll machine the back side of each piece. So let me get this all smoothed up and sanded down and cut out 3 more. And so then we'll take a look at the next step from there. Okay, that's the one I just parted off. I could probably sand it more. It might not be quite smooth enough. But what I need to do now, what I need to do now is make 3 more of these. Then I can put it back in a lathe this way and work on this back part here, which basically will look like that, with a little bit more of an extension in the center there, about 2 millimeters sticking out in the middle. But so yeah, I need to put that back in a lathe the other way and finish off that back side. But like I said, I'm going to make the rest of these first, and then I'll make a mandrel or something to hold it so I can do the back side. But I think that's looking pretty good. So again, just to be clear, there will be a row of holes along here, something like that, all the way around, and a row of holes here, around there, something like that, all the way around, for the spokes. What I really need to be careful of is when I go in the back here, when I make this recess, to not go too deep, because if I go too deep, then I'll get into that sunken down part there, and then I'll have 2 pieces, which is what I don't want. So as far as I can tell, making the wheels is going to come down to like 4 major hurdles. One is making the center hub. The second hurdle is making the outer hub, making this outer hub, which I still don't know how I'm going to do that. I could get a big piece of brass and machine it out, or I could try to take some flat pieces and make like a mandrel and a die and kind of press the shape into it, maybe? I don't know. So I still have to figure that out. And then drilling all the holes in here and around in here, and then rigging it up to actually put the spokes in. So, and it's just one of those things where I'm just focusing on one step at a time, because I don't know how I'm going to do the other steps yet. And maybe that's going to get me in trouble later. Maybe I should plan out the whole thing first, but I don't know. I have a feeling that the wheels are going to be like a multi-part series. Like, I think just finishing these will be one video, and then the outer parts will be another video, and then the spokes will be a third video. I don't know. I'm still just making it up as I go along. But let me get 3 more of these done, and then we'll just figure out the next step. Okay, I'm not going to like toot my own horn or anything, but I don't mind bragging a little bit about the way these turned out. And they need a little bit more sanding and polishing before nickel plating, but since I still have to drill holes and stuff, I don't want to get too carried away with sanding and polishing yet. But I tell you, man, those came out a lot better than I was expecting they would. And I also tell you that I don't think I could have made all four of those exactly the same without that digital readout. That kind of really saved the day for this one. So if we take a look at these, I did modify this wheel to fit the kit with those brakes, you know, just in case my wheels don't work. That's what it would look like. I basically just had to bore the hole out a little bit. And so if I have to, you know, I'll use those. Again, I keep saying it. Those don't look terrible. But if we take a look at how that fits and just put a straight edge along there, it's pretty much even with the outside of that wheel. And so then if we put that on there and we check that again, it's in just a tiny bit, which is perfect because that means all I got to do is put a little washer on the backside to space it, and then it'll be right where it needs to be. So I do have a little bit of movement back and forth to get that wheel positioned, or to get the tire positioned into the hole. So that, I think, turned out pretty well as well. So I also, yesterday, I found what I'm going to use for spokes. And I went to Hobby Lobby, and I got some of these pins. I think they were called silk pins. I'm not a seamstress or a sewer, but I think they were called silk pins, something like that. I got these because of the head. So when I drill the holes, there's a series of holes that get drilled in here. I can push this in from the backside, and that head will hold it in just like a real spoke. And then the point of that, when it goes through the outer part of the wheel, and it pokes through the outer part of the wheel, I'm just going to bend it over. Now, I thought about just bending it over, maybe epoxy. I don't know how well I can solder to that. Probably not, but I'll try it. I think if I could solder to it, that would be best, but I don't think that's going to happen. So again, once it goes through the hole of the outer wheel, I'll just bend that over. And of course, the tire is going to completely hide that. And I think that's my best chance. That's my best bet. Next step for these is to drill all the holes for the spokes. So a bunch get drilled around here and a bunch get drilled around here. I don't even know how many spokes yet. I've got to look at images and count. Well, I guess I could count the kit. But right now, I don't even really know how many spokes. So, but I'm going to use, to drill these, I'm going to use a tool I've never used before on a tool that I've only ever used once. So let's go over to my side bench and see what that is. So this is my CNC router, and I got this probably 4 or 5 years ago, and I don't even have room for the mouse and the keyboard. I need to build a little table or bench or something there. For now, that's okay. I used to have the mouse and keyboard over there before I got the milling machine, and I've got my screen right up there. But anyways, so I got this thing like 4 years ago, and I was in such a hurry to get it. I was so excited to get it, and I've used it one time. And that was just to scribe some detail lines on a flat piece of plastic for a robot commission build I was working on. And even that, I screwed it up. Because I'm having a hard time learning like the G code and stuff. So I'm having a hard time figuring out the software. I mean, I'm getting there. It's just taking a while. But the rotary piece here, I just installed this onto the machine yesterday, and was playing around with it a little bit yesterday. I've never actually used this, but last night, like I said, plugged it in, turned it on, and I was just playing around with it. It is not calibrated. Like when I tell it to turn 360, it goes a little bit more than that. So I need to fine tune this so that the dimensions, the degrees are correct. And also what I'm thinking is, I've been reading a lot about G code and just writing your own G code. I only need 2 operations here. I need to drill and then rotate and drill and rotate. Obviously the piece here will go in a little mandrel like right there. And so drill, rotate, drill, rotate. So I only need like 2 operations. So I'm thinking what I'm going to do. Once I get that fine-tuned, I can just go to the screen there and I can just write my own sketch, my own G code, and hit go. And instead of drafting that up in CAD and creating all the cam and all that kind of stuff, I only need 2 commands. So that's what I'm going to try. And if you remember, fortunately, I have a screwed up piece that I can practice on. So that's the plan, is to practice on this one, make sure it works, and then I'll put those in and drill the holes there. So I need to spend a few hours figuring out and calibrating the machine, and then we'll get that set up and see if we can get some holes drilled. So I'll get back with you here in just a minute. Okay, so I'm kind of glad I screwed one up because I have a practice piece for drilling the holes. As you can see, I've started drilling some holes in here. These are not, they're kind of groups of holes just for practicing. And I've tried a few different bits, getting some different sizes depending on the bit that I use. So I found the right bit that I need to use, and I've figured out the G code to get it to drill and rotate and drill. And when we take a look at these holes, I think I've said this already. I don't remember. But there's, around this area, there's going to be 48 spokes. So there's actually a row further out here and then another row about here. So there'll be a hole here, then one here, so forth and so on. So there's basically a hole every 7.5 degrees. So I'm working on just writing G code to have it drill, rotate 15 degrees, drill 15, and then once I get all the way around, I'll manually jog it over 7.5, and then in maybe, I don't know, 1, and then just run that whole script again. And this is one of those things where I'm having to learn how to write the G code like that because I don't know all the G codes. So I've gone to like multiple websites because it's like you do a search on G code and you'll find a website that explains some of them. And so you have to go to another one to see some others, and some websites will explain them in more detail than others. So I'm kind of having to like do a lot of back and forth reading between different websites to get the information I'm looking for. But so far it's coming out okay. I made one more minor change to the code. I'll show you here in a minute. And then I'll do one more practice run, and then I'll do the real ones. Now I could write the code to drill a hole, rotate 7.5 and move and drill, rotate 7.5, move back and drill, and just back and forth all the way around. But that would be twice the amount of lines, twice the amount of code to write, and that would give me much more opportunity to screw up. So by doing half of them and then manually moving it to a new point and then running that same script again, I'm a lot less likely to screw up. So that's my plan behind that. So let's go over and take a look at the G code. All right, so I'm just using the free software that came with the unit, and so we'll get that started here. It's the CNC motion controller. It's just, again, this is just the free cheap software that came with the CNC machine. And I never registered it, so I gotta go okay here. And it gives me an evaluation error because I never registered the software yet. And so right now I'm limited to what I can do. A lot of the features are disabled because I've never registered this yet, but it'll still do exactly what I need it to do. If I use this machine more, this is the second time using it in probably 5 years. If this was something I used every day, I would just download like Mach 3 or something like that. But I'll go here, I'll import my G code. We'll do that one. And it's right there, but just so we can see it better. I'm going to go here and edit G code. So this is it right here. So just to give you an idea of what this is. Now again, I had no idea how to even start a script. I don't even know if it's called a script. I'm just calling it that. If it's not called a script, feel free and leave a comment. But the first line is a percentage sign. I didn't know that. So basically what I did was I loaded a random sample script and I deleted everything except for the first couple of lines because I knew enough to know what a movement was. I knew that a GO is an axis movement. So I deleted everything up to the first GO command. So it had a percentage sign and M3. I have no idea what M3 stands for. I guess I could look it up and find out. So I left those there. It works with it. I have not tried getting rid of it to see what happens. So I just left it there. I guess I'll look it up and see what it is. And then G21 and G90. Those were not there. I added those because doing my research, looking through different websites, I apologize about the shaky camera. I'm trying to hold it and talk at the same time. I forget which one is which, but one of those means metric versus imperial. And again, I forget which one it is. Maybe it's G21 means metric, and maybe G20 is inches, or G22 is inches. I forget. And then the other one is telling it whether I'm using absolute values or relative values. And I decided to use absolute values. And again, that could have been this one. Like I said, I forget which one is which. But those two G numbers right there are telling the machine that I'm using millimeters and I'm using absolute values and not relative values. And then I just told it to go to X0, Y0, Z0, A0. I probably don't even need that there because when I start it, I manually put everything at 0. So I probably don't even need that, but that's telling it to go to all the 0 positions, which again, I'm starting at 0, that's probably not needed. And then I tell the Z, which is the drill bit, I tell the Z to go up to 0.2 millimeters just to clear the work. And then this one right here, the G83, that is a Peck drill cycle. I decided to use a Peck drill cycle, and what that does is it lowers the drill bit, then lifts it up, then lowers it and lifts it up, and lowers it and lifts it up. It's like pecking the hole through. I did not want to just send the drill bit through all in one motion because I was afraid of breaking the drill bit. So G83 is a Peck cycle. So Z tells it that I want it to go down negative 2.75. So that's how deep it's going to drill. And what it's going to do is it's going to go down 0.25, and then it's going to come up to 0.2. And it's going to do that at 25 millimeters per minute. So this whole line of code right here basically says, okay, go down 0.25, then go up to 0.2. Then go down 0.5, then up to 0.2. And then down 0.75, up to 2. And it keeps doing that until it's drilled down to negative 2.75. And again, at a rate of 25 millimeters per minute, which is kind of slow. That is really slow. But again, I don't want to take any chances of breaking the drill bit. And so it drills the first hole, then it goes up 0.5 millimeter to clear the work. And then GO A15 is to rotate 15 degrees. And then it Peck drills another hole. And then it lifts up to clear the work. Then it rotates to 30 degrees. So what I need to do is just cut and paste all of this multiple times and then go through and just change all of the A values. So it's going up to 360. So again, I just did a couple of drills just for testing. I didn't want to write the entire thing and find out that there's a mistake. So I just do a couple of holes. Also, it has to end with a percentage sign. I didn't know that till it gave me a warning to tell me to do that. So let me put that practice piece back in because I did make a change here. I made some minor changes to the Peck drilling. So I want to do this test again. And if that test works, then I will complete all of this to do all of the holes. And then I'll put a real part in there and drill the holes for real. So let me get that scrap piece put in and I'll show you what it looks like. All right, so I'm just going to hit go right here. That's going to start it. Notice I have everything zeroed. So when I select go, we should see it start drilling. Now, I stopped that, well, for some reason it stopped. So it did this to me yesterday on the practice drill, and I'm not sure why. By the way, that's a 0.7 millimeter drill bit. So I'm having a hard time focusing and holding it still on that. So it did this to me yesterday for some reason, and I'm not sure why. It drilled the second hole, but it never went up and rotated. Again, there's the code right there. So that's the second hole. It drilled the second hole, but it never went to the next line. It didn't go to the next line and then rotate. And I'm not sure why it's doing that. So I got to figure this out, then write the whole thing, and then put a wheel in there for real and see what happens. So we'll get back to you once I get that figured out and I get an actual part in there. Okay, so since my software that I'm using is not registered, and I can't register it because the computer is too old, I can't go online with it. Plus, I think the company or the website that makes this, I couldn't even find it. It's limiting me to how many operations I can run. That's pretty much all I can do, which is like 2 holes. So I re-zero the A, I hit start, it gives me the warning that I'm not registered, and then it'll drill 2 holes. The fan right there is out of balance. That's 99% of the noise of this machine is that fan. So it'll drill 2 holes and then rotate to the next spot. So I basically zero the A, and then I just hit start. And it'll do 2 more holes and rotate, so I zero the A and hit start. So I just got to do that till it's all the way around. And then I can offset it 7.5 degrees to do the next holes. So that's how it's going. So I'll show you what it looks like when it's a little further along. So it's gone all the way around once. So I manually rotated to 7.5 degrees and shifted it over 1 millimeter and started it all over again. So it's working on the second row. And then once that's all the way around, I'll have all 48 holes. And then I'll need to do all that 3 more times. So I'll show you what that looks like when that one's done. Okay, I'm not going to brag, but I will say I did a great job with that. And when I say I mean my CNC thing. I am just really happy with the way that turned out. I was so afraid the drill bit was going to break or wander off, or the machine was going to screw up and do something weird and screw that up. But I'm just really happy with that. So obviously, you know, I did some looking up and to see how the wheels are made. And, you know, with all the research and looking up, they are 72 spoke wheels, 48 along here and 24 along here. So the divisions were easy. You know, these are every 7.5 degrees. These are every 15 degrees. So the math worked out easy. And the CNC router that I bought 5 years ago and have only used once prior, did really well. The only issue is, as I said before, I need to get new software for it. I need to get a new computer that I can actually get online and get new software. Because what I had to do is drill 2 holes and just hit start. Drill 2 holes and hit start. I could only run a program long enough to drill 2 holes. So it took a little bit more time, but I really don't care. I am just really thrilled with the way that turned out. Now, I kept saying that the kit parts don't look terrible, but now that I know how a wheel actually is, yeah, these, I really hope I don't have to use these. If my homemade wheels turn out like garbage, then I'll use these. But I really hope I don't have to. These are close. There's the correct number of spokes here, but they come to a single point instead of overlapping. And that row here should actually be on that side, and the spokes from here should come to here. And these are completely all wrong. Wrong angles, wrong number, where they come in is wrong. Now, I know why they did this. They had to do this in order to make the castings. This was about the only way they could. So considering how they had to do it, again, they're not terrible. I just would rather them be more correct is all. So again, if the ones I make just come out looking like garbage, then I'll use these, but I really don't want to have to do that. Now, I still have to do the other 3, right? So I have one completed. And the other 3 are about halfway done, except for the nickel plating, obviously. But I'm going to end this video here with that part pretty much done. Because the next thing I need to do is the outer wheel, which right now I'm not exactly sure how I'm going to do that. But before I can make the outer wheel, I need to know the shape in here for the tire. And I cannot use my tires that I have. This one is probably the best one. And it's got a divot in it from the way it was stored from the previous builder. Plus it's got glue all over it. The other tires that I have are really badly flat spotted, like really bad, like dented in, flat spotted. And some of them have swollen a little bit and they fit loosely on the wheel. I mean, there's like a 2 millimeter gap and they just rattle around and fit loosely on the wheel. It might be possible to put them in hot water and get them back in shape, or stuff foam in it to get them back in shape. But, there's just too many issues with all 4 of the tires. So what I did was I ordered a D'Agostini tire from a seller on eBay. If you're not familiar with the D'Agostini kit, and I apologize if I'm not pronouncing that right, but if you're not familiar with that, That is those model kits you get as a subscription. So every month you get more parts. So you might get, in one issue you might get like a tire with a headlight. In another issue you might get a seat with a door. You get like a couple of parts a month for a couple of years, and you can assemble as you go, which I don't know if I would like that. I mean, and plus they're expensive. But anyways, long story short, issue 3 of the D'Agostini kit is one tire and a steering wheel. And I am going to need a steering wheel. Here's my steering wheel that I have right now. And obviously it needs some help. So issue 3 has a tire and a steering wheel. So I got that for like 40 bucks. That's including shipping for 40 bucks. Worst case scenario, I got a $40 steering wheel. But I'm assuming the D'Agostini tire probably won't have the exact same profile here. So I need to get that tire to find out what shape the outer wheel needs to be. And I'm not going to get that for another probably 2 or 3 more weeks because it's coming from overseas. So it's going to be a while before I can start the outer wheel. So while I'm waiting for that, I still need to finish the boot for the steering, and I need to drill the other holes in the other 3 center hub parts. So it'll be a while before I can get another video out for this. So my next video will probably be a simple model kit or something, maybe that milling machine model kit. You'll also notice that the drill bit got kind of rubbed against that flange along here. I'm sure you noticed that. That'll be an easy enough thing. I still got to put these back in the lathe and polish them up, so that'll be an easy thing to sand that out when I'm polishing these up. Because these need another like final sanding and polishing prior to nickel plating. So I'm not worried about those little marks. But anyway, so that's the plan for for finishing up the wheels. That's going to be it for this video, and I appreciate everybody who watched through to the end. So as always, until next time, thanks for watching.